Okay, man. Yeah, no worries, man. Whatever works for you.
Yeah, I gotcha. No worries.
How the moving goes.
Can I get a soft whenever?
Yeah. For sure. I just wanna, before we get started, I do want to just say that I am more convinced that our time on this planet is shortening thanks to Justice Metzger.
That's not me. That's not me.
I told you I have 3 socks so far. Okay, what is this one? This is a diesel stack? Oh man. All right. So here's a diesel stack. Okay. And so just remember everyone that these socks were all the same, right? So they all started off, well, this is Emily. She drives like less. Yeah. Yeah. So it's a little dirty on the inside. You can see some of that, and that might be from just being on the tailpipe there. Okay, and then this is the Suburban. This is a 2011. Nice. Oh, Subaru. Oh, I don't know how to read. Okay, there's a Subaru. Okay, I expected that Subaru to be a little bit better than this. Okay, and it's not diesel, right? And this is a Duramax. Oh man, this is definitely one of the best of all times. I mean, and by best I mean worse. Okay, yeah.
Wait, what is attached to
We
the
were
sock?
doing that, like, we were trying to get it that way.
All right.
It was not driving normal.
Okay, all right. I'm gonna give you another sock. I want like normal. Can you just drive normal?
Yeah.
When you said we, who was with you?
It's Connor Lauer's truck.
Oh, okay. What, will you see him again?
Yeah.
Okay, all right. We got to compare the normal. Okay, so I'm gonna leave these at the back of the room, and then so what I want you to do is I want you to write your name on it, and then the year. If you also want to write like how far you drove, or like how far were both of these on the way to school?
That was on the way to school. Him was just like him driving around the block.
Okay, around the block.
So,
Oh my God.
on purpose.
Oh my, that's amazing. I mean, I'm pretty sure I can get high off of just sniffing this right now too, man. It's a good smell. It's like markers and socks and been on diesel. Hey, so I'm gonna leave this in the back of the room. Okay, cool. So, yeah, label. This is pretty good. Right. But like, okay, so you live on Wayne Street, right?
Yeah.
You still live on Wayne?
Yeah.
So you and what street do you live on, Emily?
I live on something right across from the college.
So he's driving shorter distance than you're driving.
Well, we're probably about the same.
Yeah.
Wayne Street's close, so I have to go around.
Ooh. All right. All right.
Like 0.7 miles.
Okay. They hacked down trees in front of your house, man?
Yeah.
What a drag.
Yeah.
Horrible.
We got like a glass top porch. I would get put out there after it come down. It was like 100 degrees.
Oh, I bet.
When it was like storming, my neighbor's trees are like pretty much dead. You really need to cut them down, and they like fell on the power line.
Oh, man.
Lose power. Yeah, I figured.
So you hate trees is what you're saying.
No, I don't hate trees. I hate his trees.
Not just any trees, his trees. Yeah, yeah. All right. Hey, real quick, do me another favor too. If you're not on Remind, get on it. Okay. So, and this is what I got. Okay. Just remember I can be with you in just a quick second. Okay. So, do you want to see the list of who's on the Remind?
Yeah.
All right. So yeah, if you get texts from me this summer, then you're on it. But then I noticed there's a lot of people. I started to go through this because I was getting rid of people who were not on it anymore, or I mean, not in the class anymore. And there's a couple people. Let's see. So Elijah, Emily, Emma, Erica, Hallie, Jeremiah, Justice, Cage, Kayla, Lily, Luke. I gotta get rid of Luke. Hey, whatever happened to his leg? Maybe.
Oh, we were on boards in practice, and he went to step back,
Yeah.
twisted his knee, hopped.
What is it? Was it torn muscle? Yeah.
Wait,
Like,
didn't
it looks
he
like the
dislocate
MCL.
that knee?
Yeah.
Yeah, his doctor said that
Maggie.
it tried to dislocate again. And that's what, like,
Because like this whole side, the medial side of his leg was just.
yeah, it's pretty colorful.
Who's the best, by the way? Is anybody? Is this? Do I know who this is?
It says it's a parent.
Yeah, I know it says it's a parent, but I have no idea who it is. I don't know. It won't tell me the phone number, but I don't know how this person like found me, which is
You can
weird.
like call them, send it a message.
Is their phone by it? Where's their phone?
It's not just click send message.
Calling not available.
Just need to control
Click
and do.
send message.
I think on Remind, I won't let you see the phone number once I want.
Are you in my APES class? There we go. And I gotta turn replies. How do I turn replies? Turn on replies. Okay. You need it? You got it? Okay, cool, man. That was the easiest fix ever. Okay, so if you're not on there, get on there real quick. That would be awesome. So you just text this to HB98H. So 81010 on your telephono. Okay, and you can get the app if you want. You don't have to get the app. Okay, it'll automatically just text you. But I'm going to use this quite a bit this year for a wide variety of things. Eventually, Mr. Self told me that we are going to have access to Parent Square. Like kids will have access to Parent Square. So there could be a APES Parent Square. And I know, I don't know if your parents are getting those. We get about 1,000 Parent Square emails, like from as a teacher and then as a parent to elementary kids, you know. But I like them. You know, we get some from Ira's teacher, some from Linus's teacher. So at 2HB98H. Okay. H is in hello. B is in but. Okay. All right, we got it? Okay, no worries. Remember, once again, the sock is due Friday. Okay, so you work 30 points. That's your homework for the week. Tomorrow, which is Wednesday, I will be pushing out the homework assignment for next Wednesday. That's going to be chapter 2 in your book. I'll talk a little bit more about that tomorrow. Everybody good now? We good on that? I don't know. What's that, man?
I was saying it was a shame about Luke. He was one of our better fighters.
Oh, yeah. He's out. Bummer. yesterday kind of seemed, the theme kind of seemed to be corn, right? Okay, man, water makes corn. I giggled that about it a couple times. Oh yeah, you want to see your sand? Okay, let's take a look. See. Thanks for asking. Here's our sand. Still looks pretty wet, but guess what? No water on the top. So yesterday, Emma, we were talking about ecosystem services. So, I'll stick my finger in there. Ecosystem services. What does the ecosystem give us? One thing that people said was water. Gives us water. And so we talked about where water comes from. And in the town of North Manchester, our water comes from the ground. So we did this little experiment. Here's what it looks like on the inside there, Mags. And we filled this thing up with sand, and then I filled water up all the way to the top. We talked a little bit about the water table, and then I left just a little bit of water. So we have a goal, okay? And our goal is this. I want you to write this down somewhere in your notebook where you won't lose it. When do you think all of the water will be evaporated? Like, give me a date. Like, is it September 9th? Is it October 20th? You know, is it May 31st? You know, when will all the water be gone? And right now, it is still very wet. It doesn't look like there is the only water that's evaporated was off the top. So we'll see what happens. We'll check this. Keep checking this. Thanks for asking. All right, yesterday we left with the cliffhanger of like, what is, do we have enough food to feed the planet? Okay, and we were like, yeah, maybe we do, maybe we don't. What do you think? Yeah, we do. Most people would say that we do have enough food to feed the planet. Then why are people starving? It's not a food abundance problem, it's a food what problem? Distribution, right? But that includes waste, right? Okay, so a food distribution problem, right? So we've got enough food, but if you drive around Indiana, you're going to find, you know, lots of places that look like this. Tons and tons and tons of corn. Okay, and this corn, for the most part, is going to be used not to feed people directly, but to feed what? Animals, right? Now we might use this corn to make something else that's not so healthy for you.
Whiskey. Without hesitation.
I was baiting you, man. I was like, you better do it, man, because I saw him in the hall. We were like talking about corn again. He's like, whiskey. I should have said that yesterday. Here's your chance, right there. It is. Okay, yeah, could make some whiskey. Okay, ethanol, right? Okay, but I'm not. Well, I might want to drink some of that. But might make you do some crazy stuff, right? Okay. Yeah, right. So pop, and what's that in the pop?
Corn syrup.
Yeah. What do they add to that? Not just corn syrup, but what do we call? What are the two words in front? High fructose corn syrup, right? Okay. If you look at, we should do a little. This should be a homework assignment at some point. Go to the grocery store or go to your house and just list the number of things that have high fructose corn syrup in it. You will be shocked at the things. I mean, like chips, right? Some chips have high fructose corn syrup in it. You know why they put that in chips? Tastes good. Yeah. It's going to taste a heck of a lot better with a little bit of sugar, okay? But if it's high up on that list of ingredients, okay, you know, it's not that good for you. Yeah.
You know how hard it is for your body to break it down?
Oh, yeah. I'll show you later when we talk about food production. I'll show you how to make it, and it's insane how you make high fructose corn syrup from this stuff right here. Okay, it's really nuts. So, Okay, so yeah, we might make ethanol for cars. Okay, we can make ethanol. We're in the heart of ethanol country, right? Poet, right down the road from us, makes ethanol. Okay, Claypool. What's the name of that place in Claypool? I forget its name, but there's an ethanol plant there, right? And they're still producing. You know, they make ethanol for vehicles and other things. All right. So we have grown food and we're doing it very well. But what about, so this is ecosystem services. What does the environment do? You're like, man, environment's not doing anything for me. I plant the corn, I till the fields, but what's the environment doing to help grow the corn?
Water.
Okay, water. Okay, so we got precipitation, right? Okay, thanks,
Sunlight.
Earth. Sunlight, fantastic. We may provide water, okay, but we would pump that water from, we'd pump that up from the ground, so it's still coming from somewhere. Ooh, I was gonna say this. You know, in Indiana, not everybody gets their water from underground, right? Name 2 other places where you can get water in Indiana. Yeah. Rivers and lakes, right? Yeah. Yeah, sure. Reservoirs. Yeah, absolutely can do it from reservoirs, right? So that might be still blocking a river, right? Okay. And I was looking for rivers, one, lake is 2. So some people in northern Indiana, they actually get their water from Lake Michigan. Okay. Which is weird to think about, right? Because I peed in Lake Michigan. Okay.
It's always so cold.
Right? Oh yeah. Ooh. Okay. And then in down south, Turkey Run area, you know, those people get theirs from Sugar Creek. You know, that's a pretty big. They call it Sugar Creek, but it's a pretty big river. Okay. So yeah. So definitely water. Okay. What else is the earth helping us with? Yeah. Nutrients, right? We're going to talk about nutrients a lot for plants. Okay. Give me one plant nutrient. No, I was hoping you'd go for that. Okay. Can we just get, is there just like an abundance of nitrogen? You know? Well, yeah, it kind of depends on who you're talking to. Okay. Can we get nitrogen, okay, without like putting ammonia anhydrous on our field? Okay. Where's the nitrogen coming from, Dyson? Okay. Soybeans. Okay. Absolutely. We will actually dissect a soybean and look at the inside of the root system and look at this little bacteria called rhizobium. It's cool, man. It's real trippy cool. All right. And okay, so we can get it from that. Okay, so how does the soybean get the nitrogen? If I'm not putting like anhydrous on the field, okay, that soybean's like somehow where's it coming from? What? It has to get it from somewhere that it fixes the nitrogen, so it converts the nitrogen into something usable. I'll give you a hint.
What?
The atmosphere. The number 1 gas in the atmosphere is not oxygen,
Carbon dioxide.
not carbon dioxide. It's nitrogen. You're breathing in more nitrogen than you're breathing in oxygen.
Oh,
Okay.
real?
Oh, reals. It's the number 1 gas in our atmosphere, but it's not readily available. Like until I think it was 1942, the only nitrogen, which is a very important plant nutrient, okay, was only available from the atmosphere in soybeans and trying to do crop rotations and stuff like that. And then these 2 dudes came along, Haber and Bosch, and they figured out how to industrialize nitrogen. They took iron as a catalyst and they heated it up and boom, they got nitrogen. So that's why you can like spray your fields. You've all seen the tanks of ammonia anhydrous, right? Okay. What's that? Spray. How do you put it on?
You can't, if you drill it into the ground,
Drill it in the
or
ground.
you like drag it across the roof.
Yeah.
Put it on the leaf, it'll-
No. But I mean before. I've seen people spray it like on the fields beforehand.
Oh yeah, like in wheat, you can spray it.
Yeah. I was like, man, am I going crazy here? Yeah, you could drill it in for sure. But you've seen those big tanks, right? You know, and it's expensive. I think Clay told me that it was like something like $3,000 for like one of those tanks. something like that. I don't know, but it's pricey stuff, right? So what did that do to our food production? It shot it way up, right? Yeah, huge. We could now, grow more food than we could ever grow before. Okay, but whether we knife it or we, inject it in, knife it in, okay, spray it, whatever we want to do, okay. Does the plant always use all that stuff? No. Where does it go then? In the rivers, right? How does it get in the rivers? Runoff, right? Okay, we'll talk a lot about runoff. Okay, this chart always, man, I think about this chart a lot. Okay, we're going to talk about climate change. I love to have some good, healthy, meaty discussions about climate change. Climate change will come up as much as like reproductive stuff comes up in anatomy and physiology. Just you remember, if you took anatomy and physiology, it feels like we could talk about stuff that you have to sign this paper for like every day almost, right? Climate change is the same thing, okay? So you might have a small bit of knowledge about climate change. Maybe you're thinking to yourself like, oh, okay, it's not real, okay? I don't believe in it, or it is something to believe and not believe in. We're gonna get you the facts, okay, right? But carbon dioxide is a part of our ecosystem, and it is definitely an indicator. Okay, remember we're talking about biological indicators here. Okay, now this is what's crazy. I think about this for a long time. Okay, this is levels of CO2. Okay. And here's this dotted line at 300, okay? 300 parts per million. So think about a drop of water in the pool, public pool over here. One drop of water, like let's take a drop of food coloring and I drop it into the public pool, okay? That's a part per million, okay? Just to give you a perspective, okay? Not a drop in my stock tank pool. We got a stock tank pool. Ooh. We're fancy now, my house. Okay, we'll have a pool party sometime. That'd be fun. Okay, so like one drop in that pool. Okay, that's a part per million. For 800,000 years, okay, we have never had anything above 300 parts per million. And you're like, how do we study 800,000 years ago? You're making this crap up, right? Here's how they do it. They go to Antarctica, they drill down into the ice cores, okay, and they find bubbles, okay, and in those bubbles they can extract gas and they can measure the amount of gas. You're like, well, how do you know what year it is? Ice is like soil. Over time, it can build up, right? So you guys know that if we're digging for fossils and we have a fossil down here and we have a fossil up here in that strata, this one is older, right? Y'all with me on this? Common knowledge for y'all, okay? So we know 800,000 years ago, there's fluctuations. It rose, it declined, it rose, declined, up and down, up and down. But the key is that it never went really above that 300 parts per million, okay? Now in 2008, it starts to rise and it starts to rise. Here's a scenario, maybe eventually by 2100 we'll get to 900, okay? What do you think, let's just make a guess right now. What do you think we're at right now? How many parts per million? Yeah, take a guess.
Probably 420.
Oh, great guess, okay? So there's a Twitter website that I check and I love it. It's the Keeling curve. Okay, so this dude, okay, in Hawaii put up this measuring device and it's become the standard for global CO2 levels. Okay, and the Keeling curve just means that like it fluctuates yearly. Okay, CO2 levels go up, CO2 levels go down. You know when they go up a lot is in the winter time. Why do CO2 levels always go up in the winter time? Yeah. Nice guess. Heaters, nice guess. Yep. More cars, great guess. Okay. all great guesses. Idling, dirty idlers. Yeah,
The trees aren't.
bingo. The trees aren't photosynthesizing, so what are the trees not doing? They're not sequestering
Sleeping on the job.
the carbon, right? Why are they not photosynthesizing? They're not going to leaves, right? Right? Okay, so, but that's just a little bit, okay? Okay, that's like a little blip, okay? Here's what happens, though. Keeps going, keeps going, it keeps going, keeps going up. So I started doing this PowerPoint in 2017. We were at 405 parts per million. Okay, here we are at 2018, 406. Okay, so we have 405, 406. Okay, here we are in 2019, we're at 409. And then just the other day, 412 parts per million. Okay, some people have said to be sustainable over time, we need to be at 350. Okay, we have been in the 300s for over several years now, right? Some people, hold that thought for a second. Some people say if we get to 450, we are screwed. Like there is no turning back. We cannot fix the runaway changes that are going to happen when we're at that much carbon dioxide. And we're at 412. This was the 12th. I can look and see what it's at right here today. When I made this, I thought we would get to this much quicker than we are. But I always forget that we've got like these 35-minute class periods, which is fun. Okay, Max, what were you gonna say?
Well, like, how does that number get reduced?
That number,
Yeah.
so in they have very sensitive measuring tools in Mauna Loa Observatory, and that's where they're measuring it. Let's go healing curve. Today they're saying this was the 16th. They're always like a couple days behind. So 412, still 412. There's also other places around the globe that have these places. It's just been the standard one. So everybody was like, hey, pandemic, right? Nobody's flying as much, nobody's driving as much. Like, surely that's going to help the planet. And in some ways, there were some positive changes. Animals kind of like chilled out. Have you heard some of these? I think I posted a couple articles this summer, right? I don't know if you read these, but like animals are like, they were kind of like, hey, we can hang out on the roads and we won't get hit, like national parks and stuff like that, right? Okay. But all of the data says that we would have to have at least a year plus of pandemic to make this number even budge. Okay. Yeah. I sure did. 412. Okay. So once again, carbon dioxide is a greenhouse gas, but it's not the number one greenhouse gas. Okay. If we didn't have this gas, we'd be definitely screwed as far as the greenhouse. Yeah.
So what else can we do to like lower the number besides just not use any sort of like vehicles?
Yeah. That's a great question. What else can we do? A lot of people would say the number one thing, which is going to seem impossible, is get off this. Somehow get rid of the coal, right? Yeah, driving is definitely makes an impact. We can all do small things, right? But it's got to have a bigger, and coal's the biggest thing. What's the number one greenhouse gas, though? If we didn't have this, we'd be in trouble, like big time trouble. Everybody always gets this wrong, and that's fine. Nobody knows the answer to this, maybe, and that's fine. Carbon dioxide is the number one anthropogenic greenhouse gas. That means human caused. Anthropogenic, so human genesis, human beginning. We are producing it, yes, from our mouths. Okay, we're going to do a fun little experiment, hopefully next week, if I can figure out how to do it. And we're going to look at how, where the carbon dioxide is coming from, basically. Okay, but it's not what's really keeping us warm. And we want to be warm, right? We still want to be super warm. And carbon dioxide is trapping that in. It's water vapor. Water vapor is the #1 greenhouse gas. Definitely like make a mental note of that. That's a great like Jeopardy question too. You know, like because everyone always says, oh, carbon dioxide is the #1 greenhouse gas. Well, it is human caused, #1. Okay, methane's right up there too. Like carbon, that kind of stuff. But water vapor, without water vapor, we'd be in trouble. And you guys all know water vapor thanks to the wonderful humidity, right?
Exactly. Right.
Water vapor is the #1 greenhouse gas. If you want to. Okay, but we want to trap some heat, right? Yeah.
Okay, but some people seem to have like such ideas.
Yeah.
Some people like get rid of all the cows.
Yeah. Right. No, none of it. When I say get rid of like the coal, I drove my van to school, right? So I used a fossil fuel to get there. You know, I like lights. I love my technology. I love this computer. You know, I love all this stuff, right? I have to have it. You know. So how can we transition? I've read some really interesting things about like, does becoming a vegetarian, is that mean that you're doing a better job for the planet? So, there's a great book. Oh man, highly recommend this one. Do I have it here? It's called Call of the Reed Warbler, and it's all about sustainable farming in Australia. Oh man, maybe it's at my house. I'll see if I can find it and bring it in. Why don't I have that here? Maybe I gave it to somebody and they still have it. But they say we need animals to regenerate the land. A lot of it's like not maybe just getting rid of it, but like how we do it. You know what I mean? How can we be sustainable? Do you know what I mean by sustainable? You guys know what that term means? Just means like I'm going to use my resources, but I'm going to save enough for my kids and my grandkids and their grandkids and so on and so forth. So, please, anthropogenic, know that term. Human genesis, right? Human caused. Okay. What time are we at here? I can't get used to this schedule. Let me do one more slide and then a couple more slides here. Okay. Wait, you want me to go back to that for a second? Sure.
So is water vapor, you said it's a greenhouse gas, right?
Yeah.
So is that considered a bad thing?
Nope, it's a good thing. It's not
So
human
not all
caused.
greenhouse gases are bad.
Not all greenhouse gases are bad, right? That's a good one. Yes.
So if it does go like the point they're saying like 450, like what happens? It just
The predictions are that the temperatures will continue to rise, and we've already seen this in the United States, even in the early 90s, where there's a thing called the hardiness zone. You guys, who's my FFA kids in here? Okay, or my agriculture or landscapers, right? Okay, you guys know what hardiness zones are? Like you can't plant certain plants in an area unless it meets that hardiness zone, right? So like I can't plant like avocados here, right? I could, but they're not going to live because they're not in that. They won't be hardy, right? That's already changed. So part of the thing that's going to be interesting is that they think in Indiana, and we're talking maybe as early as 2050, okay, that we're going to maybe be able to grow some crops here. That could be a good thing, okay, that we never grew before. But immediate concerns are, do you guys remember, it was last fall, there was guys soccer game and a girls one. I think girls were supposed to go to Eastbrook maybe, okay? And there was this crazy storm. Like, I mean, it dumped like something like 3 inches in like 30 minutes. You know, it was insane. Uh-huh. All right. So y'all remember this storm? Okay. That was unlike most of the storms we have, I mean, we're talking major dumps. So that a major deuce. So they're saying, Morgan, that that's what we will expect. More events like that. Okay. But here's what's bad about that, right? Flash flooding, the rivers can't handle it. You're going to think about what that does to the fields, like creating rivers, gullies. Will the ditches be able to handle that? Right? I mean, it's crazy. So a lot more flooding, a lot more rain events like that. Yes.
So how do you know that this can be like a sort of flood time? You have like say ice age or whatever, and then warm back up.
Right.
You know, how do you know?
Right. Great. So, and we're going to get into this, but let me give you the short answer. So the ice ages are caused by global, so changes with the Earth's tilt, changes with the Earth's orbit, and then something called the wobble. Okay, so the Earth actually, so that's also a tilt thing. So the Earth is like 23 and a half. If we tilt it a little bit this way or a little bit more this way, that's that wobble. It's going to change the way the sun hits the Earth. The other is that we are in ellipsis. Okay, so if this is the sun, we're kind of going out here and then kind of coming back. That's why we have seasons, right? We're coming up on, the equinox, right? And the solstices. You guys know these terms? Okay. It'll change if it changes to a circular orbit, that would cause another ice age too. Okay, so the ice ages are a little bit different. That's called the Milankovitch cycles, and they happen every like 120 to like 1,000 years to 44,000 years. So yeah, there's definitely a chance, but some say if we get to 6 degrees Celsius, all life is done. We're done. We're cooked. We cannot sustain that. Okay, but right now we're about 1.5 degrees Celsius, approaching 2. That's going to get it's going to get crazy. If we get 3 to 4, life's going to definitely look different, and it's happening quicker than that 120,000. Hey, thanks for sticking with me. Great questions, by the way. All right, you have anything, Mags? Okay, great. Peace out. Bye.